Good morning, students. In continuation with the previous session, we studied disaccharide and three different types of disaccharides under oligosaccharide classification. So now in continuation with the oligosaccharide, we are going to start with trisaccharides. And this trisaccharide, which includes three monosaccharide units. So these any three monosaccharide units, if it combines with the help of glycosidic linkage, if it links with the help of glycosidic linkage, we get trisaccharides. So from the name itself, we know tri. So three saccharides, which includes monosaccharides. So three monosaccharides, if it is linked by means of glycosidic linkage, we call it as trisaccharides. So under the classification of trisaccharide, we have a raffinose and maltotriose. So the most common trisaccharide is raffinose, and this raffinose you will be seeing it in wheat. You can find raffinose in wheat as well as in cottonseed. So these two are the richest source of raffinose. So raffinose will be extracted from wheat as well as from cottonseed. The syrup which is obtained from the manufacturing of sucrose from wheat. So during the preparation of sucrose from the wheat, and this will be the best raw material to extract your raffinose, because that is the richest source of raffinose. So this raffinose has one molecule of galactose, one molecule of glucose, and one molecule of fructose. So these are the composition of monosaccharide of your raffinose. So galactose, which will be linked with glucose by means of glycosidic bond, and again glucose, which also will be linked with the help of glycosidic bond to the fructose. So when you hydrolyze this raffinose, you get or you yield galactose, glucose, and fructose. And this raffinose is a non-reducing sugar. So till the previous saccharides we have studied, those are all reducing sugars which can convert the color of copper, which is in color, to cupric ion, which will be brick red in color. Whereas this raffinose is a non-reducing sugar. This cannot reduce the copper, which is available in blue color, to brick red color, cupric ion. So in case of other disaccharides like lactose, maltose, and all reducing sugar, even sucrose is non-reducing sugar under disaccharide category. So in the disaccharide category, sucrose is non-reducing sugar because functional groups are involved in the bond formation, and even the raffinose is non-reducing sugar because it cannot reduce both Fehling solution as well as Benedict solution. So as we discussed in the first class, it's a carbohydrate itself. There are certain sugars which can reduce the Benedict's reagent as well as the Fehling's reagent. If it could not able to reduce, which means it cannot able to convert the blue color copper solution to brick red color cupric solution. So if it cannot able to convert blue to brick red color, those sugars you call it as non-reducing sugars. So raffinose is one of the non-reducing sugar which is existing along with your sucrose, which is a disaccharide. Raffinose is a trisaccharide, sucrose is a disaccharide. So since this raffinose is made of glucose, galactose, and fructose, when you hydrolyze your raffinose completely, you will get one molecule of glucose, one molecule of galactose, and one molecule of fructose. So three monosaccharides you will be getting. And of course, the linkage goes like this. The galactose will be linked with glucose through 1,6 linkage. So carbon 1 of galactose will be linked with carbon 6 of glucose. And again, from glucose to fructose, we have linkage of 1 to 2. So from glucose, carbon 1 will be involved, and from fructose, carbon 2 will be involved, because in fructose, the second carbon has the functional keto group. So you will have galactose, which is linked with glucose through 1,6 linkage, and glucose, which will be linked to fructose by means of 1,2 linkage. So this will be the general structure of your raffinose. So galactose, glucose, and fructose, this is 1,6 linkage, and this is 1,2 linkage, and with fructose. So this is one of the trisaccharide which has a huge amount of importances. Thank you.